What happens when a messenger from another star system arrives, but the world's most powerful eyes suddenly go blind? A bombshell has quietly dropped on the astronomical community. As many of the West's premier telescopes go dark, China has released the first new images of the interstellar Comet 3I Atlas. This isn't just a scientific curiosity, it's a major shift in who watches the stars and who tells their stories. Let's break down what's really happening.
Strange composition.
So, what makes this visitor from another star so bizarre? Interstellar objects are messengers from distant star systems, and 3I Atlas is only the third one we've ever confirmed. Unlike its predecessors, Oumuamua and 2I Borisov, this comet is giving us an unprecedented look at the chemistry of another solar system. Early observations from teams led by astronomers like Quanji Ye, using instruments like the James Webb Space Telescope's NIR SPEC, have revealed an unusual chemical fingerprint. The cloud of gas and dust surrounding it, called a coma, is incredibly rich in carbon dioxide, with some studies suggesting the CO2 to water ratio is more than 10 times higher than that of typical comets from our own solar system's Oort cloud, like Comet Hale-Bopp. This suggests it formed in a very different and likely much colder environment, possibly in the outer reaches of a red dwarf star system, with a nucleus estimated to be between 2 and 5 kilometers in diameter, and a hyperbolic trajectory with an eccentricity greater than 3. It's a pristine sample of the building blocks from a completely alien planetary system, delivered right to our doorstep. Every piece of data is a clue to how planets and life might form elsewhere in the galaxy, which is why every single observation is so critical.
Telescopes go dark.
Just as we were starting to unravel its secrets, the line went dead. The world's most powerful observatories, the household names of astronomy like the Hubble Space Telescope, the James Webb Space Telescope, and the European Southern Observatory's Very Large Telescope in Chile, have reportedly fallen silent in their observations of 3I Atlas. Now, this doesn't mean they're all broken. In reality, large telescopes operate on incredibly tight schedules planned in cycles months or even years in advance. Getting discretionary target of opportunity time is fiercely competitive, with thousands of proposals vying for a few precious hours of observation. These facilities also require regular, intensive maintenance to keep instruments like Hubble's Wide-Field Camera 3 or the VLT's X-Shooter spectrograph running at peak performance. A combination of scheduled downtime, maintenance, and pre-booked observation blocks on other cosmic targets has created a perfect storm, a temporary but critical observational gap. For a fleeting visitor on a one-way trip out of our solar system, losing even a few weeks of observation time means permanently losing a piece of an irreplaceable puzzle.
China steps in.
But the sky is never truly silent. Someone else was listening. Into this observational vacuum, China's astronomical community stepped forward, leveraging their growing network of advanced facilities, such as the 2.16-meter telescope at Xinglong Station, part of the National Astronomical Observatories of China. They released sharp, high-resolution images of 3I Atlas. These aren't just blurry snapshots, they are deep-field images that capture the comet's evolving structure with stunning clarity. Established in 2001, the NAOC has rapidly developed world-class capabilities, driven by a national strategy to become a leader in astrophysics. Scientists like Jing Li and her colleagues are at the forefront of this effort, utilizing these modern facilities to monitor transient astronomical events. By capturing fresh frames of the comet's coma when other major facilities were dark, Chinese astronomers didn't just fill a gap. They seized a moment of scientific leadership. The timing was impeccable, demonstrating that years of heavy investment outlined in their 5-year plans have paid off, positioning them to make critical contributions right when they matter most.
Data controls narrative.
Here's the bottom line. Whoever has the data writes the first draft of history. In science, the teams that publish first often shape the entire conversation around a discovery. By releasing the only new images of 3I Atlas during this critical window, Chinese observatories gain immense influence over the scientific narrative. Think about how the first close-up images of Pluto from the New Horizons mission, released by Alan Stern's team, completely defined our perception of that world for years. Their images might highlight specific features, a new jet of gas, a change in the dust plume, or a brightening event, that will guide all subsequent research. A first discovery paper on a major object can garner thousands of citations, solidifying the author's place in scientific history and influencing future funding decisions. This puts their interpretations at the center of the debate and makes their facilities the go-to source for the next chapter of this comet story. They are now in a prime position to lead the charge on developing the definitive models that explain the comet's origin and behavior, potentially defining our understanding of this object for generations.
Data sovereignty.
This isn't just about science, it's about control. For decades, Western astronomy has largely operated under a philosophy of open data, with archives like NASA's MAST providing public access. But that's not the only model. For example, data from the European Southern Observatory often has a one-year proprietary period for the observing team before it becomes public. As different nations become major players, the question of data access becomes more complex. The decision to release or withhold data can become a powerful tool of soft power. If China's new images and follow-up data are shared openly, it could foster a new era of global collaboration. However, if access is controlled through institutional channels, it could complicate independent verification and sideline researchers from other countries who lack the right connections. This situation brings up serious questions about scientific sovereignty and the norms of data sharing. Who owns data from the cosmos? How that question gets answered will determine whether the future of astronomy is more collaborative or more fragmented and competitive.
National prestige.
Look, space has always been a stage for national power. From the space race to the latest Mars missions, scientific achievements are deeply intertwined with national pride and geopolitical influence. China has been transparent about its ambition to become a space superpower, investing over $13 billion annually into its programs. These efforts include the successful Chang'e lunar sample return missions, the construction of the permanent Tiangong space station, and the development of the Suntian space telescope, designed to rival Hubble. Releasing pivotal images of a rare interstellar comet at the exact moment Western telescopes are offline is a massive public relations victory. It sends a clear message to the world. Tranin pasin so pan josar, Tranin golan doting ninensam. Adens drijers. Not Tranintan just catching up. It is a leader in frontier science with the technical prowess to deliver when others can't. The narrative that China saved the day by ensuring continuous observation of this visitor resonates far beyond scientific journals, bolstering its image as a global technological powerhouse capable of leading humanity's exploration of the cosmos.
Infrastructure fragility.
What does it say when the world's most powerful eyes can all blink at once? This episode, honestly, serves as a stark reminder of the fragility of our global astronomy infrastructure. The catastrophic 2020 collapse of the 305-meter Arecibo Observatory is a perfect example of how the loss of a single, unique facility can leave a massive gap in our scientific capabilities for years. For decades, the community has relied heavily on just a handful of flagship observatories. While these telescopes are incredibly powerful, this centralization creates a single point of failure. Funding cycles, maintenance, or technical issues can, take multiple key instruments offline simultaneously. The 3I/Atlas event proves this model is unsustainable for time-sensitive science. It highlights an urgent need for a more diversified and distributed global network, something the upcoming Vera C. Rubin Observatory in Chile will help address with its continuous sky survey. Relying on a few titans is a risky bet when the universe doesn't wait for our schedules, and a single nation with agile facilities can now step in and dominate a major discovery.
Verification questions.
Just because we have new pictures doesn't mean we have the full picture. This is where, honestly, a healthy dose of skepticism comes in. While the new Chinese images are invaluable, they raise some pretty critical questions for the global scientific community. Are these images calibrated in a way that is fully compatible with data from other observatories? For the science to be robust, the global community needs full and timely access to the raw FITS files, the standard format for astronomical data, along with detailed metadata. This is really essential for independent analysis using standard software tools like AstroPy. It's also crucial that the astrometric data, the precise position of the comet, is submitted to the Minor Planet Center for independent orbital calculations, which require precision down to a fraction of an arcsecond. There's also a real danger of over-interpreting limited data. Without concurrent spectroscopic observations to analyze its chemical composition, any conclusions about the comet's activity could be biased or incomplete. Transparency will be key to ensuring these observations become a trusted part of the scientific record.
What the images revealed.
So, what are the Chinese observatories actually seeing in these new frames? The released images are more than just pretty pictures, they're actually rich with scientific data that allow for precise physical modeling. Observers are pointing to subtle but significant details, like hints of new jets of gas and dust erupting from the comet's nucleus. These jets are crucial because they produce non-gravitational forces. They act like tiny rocket thrusters that can, subtly alter the comet's path by hundreds of kilometers. Tracking these minute deviations, a specialty of astronomers like Marco Micheli, requires high-cadence astrometry from images like these. Furthermore, brightness gradients across the coma seem to be shifting, which could suggest that the outgassing is anisotropic, happening from specific active patches on the surface. By taking many images in quick succession, the Chinese teams can monitor rapid transient events that might otherwise be missed. This morphological data provides the crucial visual context needed to interpret spectral data from other observatories, past and future, becoming the scaffold upon which a complete understanding of 3I Atlas will be built.
Global wake-up call.
This isn't a story about one comet, it's really a glimpse into the future of discovery. The 3I Atlas incident is a major wake-up call for the entire astronomical community. It has exposed the weaknesses in our current observation strategies and underscored the growing multipolar nature of space science. This event will likely accelerate calls from organizations like the International Astronomical Union for more resilient, globally distributed networks like the Zwicky Transient Facility that can provide redundant, 24/7 coverage for high-priority targets. It will also force a conversation about formalizing emergency protocols, ensuring that when a rare object appears, an all-hands-on-deck observation plan can be triggered automatically across observatories in different nations. The future of astronomy can't rely on luck or the availability of a single instrument. The game is changing, and this fleeting messenger from another star has just revealed the new rules for how we play it. The story of 3I Atlas is a powerful reminder that the universe doesn't wait for anyone. A visitor from another star system is hurtling through our cosmic backyard, and for a critical moment, China's observatories were our only eyes. This event will reshape not just our understanding of this comet, but the future of how humanity watches the skies. What are your thoughts on this shift in the cosmos? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of technology and space. Thank you for watching Sci and Why.